Welcome everyone. Today I'm super excited because we'll talk about collections. What are collections in Rust? Collections are data structures that are used to store multiple values. And a big difference with other, for example, from arrays, is that they are stored on the heap. This is a very important difference because the data doesn't need to be known at compile time. So this vector can grow or shrink during the program execution. Sometimes we need it because we don't know at compile time, I don't know, how many rows the user will use or the list of users of an application. So we'll start talking about vectors. What is a vector in Rust? A vector allows you to store a variable number of values, variable, so you don't know, and they are next to each other. This is a very simple definition because this is exactly what the vectors are. Now, we want to have a practical approach. So in this lesson, we'll talk about how to create, update, delete a vector, getting the values, changing the values. So we have many things to do. So let's start. And of course, we'll start with a simple example, how to create a vector. There are actually two ways to create a vector. There are actually two ways to create a vector. One is to create a vector. One is to using this keyword. So we can call it, for example, this vec1 in this way. We can define the type. In this case, we can have this vec with angular brackets I32. And then we can define equal. And then equal vec double colon new. We just created a new vector. We can even try to print it, using the println macro. Let's see if this does work. Cargo run -q. And as you can see here, we see the empty vector here at the top. Okay, we created an empty vector. Now, usually, when we create a vector, we have some values. Sometimes we have some values. So we can use this using a macro. So we can create a vector with initial values. And to do this, we can do let vec2, and then we can have vec exclamation point, for example, 1, 2, 3, 4, 5. This is a way to initialize a vector with some values. In this case, we decided to insert these numbers. Okay, let's try. Cargo run -q, 1, 2, 3, 4, 5. So this is very simple, two ways to create a vector. Now, as I said, a vector can store a variable number of values, and this can also be changed this can also be changed after the compile time. So, of course, a vector has some methods. It has many methods to work with these vectors. For example, let's start updating a vector, and we can type let vec3 equal. Let's define a new vector, vec3 of type vec I32, and then we type vec3.push1 and then vec3 push 2. I have a question for you. Do you think that this will work or not? We define a vector and then we use this push method. A vector has a push method, but will this work or not? Let's push 3 numbers and then let's print it. Let's see. Let's see if we get some answers. No, Jolene. Why? Jolene is on the roll. Why? Let's see. I like how she said it. No, after 2 seconds. What's the reason? If I didn't make a typo, it should be correct. It's not mutable, but because it's defined too, but maybe. Let's try cargo run -q. You were right, and Andrew is also right. Vec3 needs to be mutable. Yes, as we did with variables, I see that you start to understand the core concepts. Check how kind, if we can call it kind, the compiler is, because it says cannot borrow as mutable, cannot borrow as mutable, cannot borrow as mutable, let mute. I love this compiler. See, it's literally telling me what to type it here. Like, cannot borrow vec3 as mutable as it is not declared as mutable. It's a perfect explanation. So, vectors, by default, they are not mutable. This should not surprise you, because also variables, they are not mutable by default. So, let's add the mute keyword. Let's see if this makes the compiler happy. And yes, you see now we have this 1, 2, 3 is this one. Let's comment these print statements, otherwise it will be crowded soon. But yes, so we can use this push function to modify an existing vector. In this case, we are adding some value. I want to show also the pop function, vec3.pop. For example, let's get this print back, and then let's print it. If you're familiar with arrays, you already know probably what's gonna happen. Okay, we get a warning because it's intentional, okay, but we get 1, 2, 3 here, and then just 1, 2. So you see the value number 3 has been popped, it has been removed, okay? Now, I want to remove this, and okay. And now let's talk about accessing elements in a vector. We can read them, also modify them. Now, to read elements of vectors, so read. So this is reading elements. It's like accessing values in an array. So let's define one more vector. Let's define, for example, a vector of characters, in this case, a bit different, let's see, A, B, C, D, E. So this will be easier. And then we can define this, let fourth, the fourth element, which is of type let's say this at char, and then at vec4 3. I remember you that as we do with arrays, we start counting from 0. We have a reference to this vector for element. Let's print it. In this case, the fourth element is cargo run-q. The fourth element is D. I want to, okay, let's remove this, otherwise we'll still have, it's complaining that we are not using the vector number 1. Okay, let's get the prints back, so we don't get the warning. You see, the compiler is super annoying. The fourth element is D. Okay. So, and this is one way to access it. There is another way using the get method. So, in this case, we'll take the fifth element, in this case, like this. This is of type option at char. And then in this case, we want to get the fifth element. So, the element in position that has an index 4, which is the fifth, because we start counting from 0. Now, after this, we can type a match statement. This is correct. And let's read it. Match fifth. And this is why I love the match statement so much. You see, we have some and none, because this fifth is of a type option. Now, if you check the line 36, this was way easier, because here we were just accessing the element number 4. Here we're doing something which seems more complicated, because it is more complicated. We are accessing this with the get method, and then we have a match that is if matches the arm sum, it will print the value, and if it's known, it will print there is no fifth element. What's the advantage of having this approach? The fifth, oh, I love it. Wow, amazing. Great. Okay, I didn't think about this. Now I regret, because I could have put this in the recording. Otherwise, good reference. Good reference. There is also the fun word. Amazing. This is clip worthy. So if we type cargoran-q, we see the fourth element is D, and the fifth element is E. You can see here we have the fourth element is this D, and the fifth element is this E. Okay. Now, what's the advantage of the second approach to compare to the first one? It should be clear as soon as we start making some mistakes. For example, if we type instead of 3 the index number 30, which is obviously not here, and we try to execute this program, thread main panicked at vector, it knows exactly the line, but it basically panicked. In other words, it crashed. So the program crashed. It panicked, it means crashed in the program. Let's say exits is the program exited in a strange way. We will see the panic mode and the panic thing in a couple of weeks, 3 weeks to be precise. But you see what's the difference here. Now I want to comment these 2 lines and try to do the same here. We can type an index 100. And what's the output here? You see, the error is handled. There is no fifth element. So we can handle, because the get method returns sum with the element or none. I remember you that we don't have the null keyword in Rust, but we have this, which is, I think, very convenient, having this sum and none, and we handle this. For example, in this case, we can print it, but you see the program didn't crash. Okay, this is a great advantage, unless we really want the program to crash. If we want intentionally to crash and exit, we can still use the other approach. Kernel panic, yes. Okay, nice. 1 second, a small break. This is a very important lesson. By the way, I really love doing standing live streams. I love it. I should have done this way before. Okay, I want to type here. Okay, now let's understand how we can iterate over the values in a vector. I want to make 2 different cases. In one of them, we want just to read the values, and in one of them, we want to iterate and also change the values. So let's create another vector. For example, we can have vector 5, and in this one, we can have again 1, 2, 3, 4, 5, and then we can use a simple for loop. We're talking about iterating over values. We can have a simple for loop. We can have a simple for loop for I in with a reference to the vector, and then we can print the values in the vector. Okay, let's try cargo run -q. I did a mistake. Okay, I did a mistake here. back 5 like this, of course. Okay, and now it works. Okay, it was you see how easy it is to do a dumb mistake. Also, intentionally, I didn't put the Rust Analyzer on. There is an extension called Rust Analyzer. Sometimes I disable it to make my questions, but usually if you code in Rust, you might have this Rust Analyzer enabled, so this would have been a dumb mistake solved, of course. Okay, so this is to iterate over just the values of an array. Now, if we want to change the values of an array, for example, we can define a vector, a mutable vector, 6, and this can be, I want to change the values here, 10, 20, 30, 40, and 50, okay, just to differentiate it from the other one. Let's say that we want, I don't know, to add 1 on each of the elements of the vector. We can do still a for loop, but it will be a bit different, because it will be for I in. This has to be mutable, of course. I want to add just 1. Something a bit strange here is what you see on line 56 is this asterisk before the I. This is called the dereference operator, and we'll have a specific lesson about it. But basically we are dereferencing this reference. It sounds weird because we really want to modify this array. And now I want to print it. Let's print the vector 6 after this iteration. And we can see 11, 21, 31, 41, and 51. Okay. It's okay. Okay, so we used this the reference operator. Okay. We are almost done, but I still want to show you a couple of things. One is, what if I want to store different types in a vector? Because at the beginning I told you that a vector is to store variables next to each other, but a vector has a type. How can we store different types? We can use an enum. So we can store multiple types in a vector using enums. I made a lesson about enums, so if we want to know more about enums, just check it out. Okay, we can define this enum, and I want to use as an example that we have a row in an Excel or a Google Sheet. That row can have multiple types. We can have a text, we can have a date, we can have an integer, we can have a float. Okay, so in this case I define an enum with, for example, int, float, text. Different types, but they are all spreadsheet cells, basically. Now we can define a row of this cheat sheet in this way. For example, let's say that we have an integer, then a float, then a text, and then, for example, we have another int and another int. Okay, like this. For example, 6 and 9. Okay, so you see how powerful this is. We can use enums with vectors. So an enum can be a type of the vector. This is super powerful. I really love this. 1 second. Okay. Let's see. It's very powerful. Yes, Bob. I'm sure that the multidimensional vectors, they exist, like matrix. So yes. But here we are focused on the basics. But it's a great question. So we have this, and now we can print this whole thing. Let's try to print this row. Ctrl L, cargo run -Q, and we have an error. But let's don't panic, and let's read it. Spreadsheet cannot be formatted using this colon question mark. It's also suggesting what we should do, adding this derive debug at the top of the enum. Okay, by default we can't print enums, but if we add this debug, say decoration, I don't know how to say it, we can try to do this. Now, I noted that this worked, but as you can see, it also printed many warning statements. So I want to show you how you can remove these warnings, especially if you're doing a tutorial or a live stream. You can allow this dead code, and if you do this, cargo run -Q, you can read it here on this line, int3, float, text, int, and int. Okay, so this is how you can store multiple types in a vector. You can use an enum as a type of a vector. Very powerful. Last thing that I want to talk about is what will happen when the scope ended. For example, here we have this curly bracket on line 80. I just want to tell you that here all the vectors go, no caps, but here all the vectors, they go out of scope. So all the vectors are freed here. We should be careful here because everything that we have inside the vectors, it will just be freed at the end. But this is similar and exactly what happened with variables. So at the end of this scope, since they are stored on the heap, they will be freed. We need to know this. And this is the end of this lesson about vectors. I will leave below a link to a GitHub repository that contains all these examples. If you have any questions, just write them below, and see you in the next video. Bye.